Hello, my name is Aditi Sen, and this is my web. This is a presentation of my web tutorial on XSS and Noxes. So this is where I uploaded my web tutorial or website on the Puzzle account of the university, and you can get it from there by just puzzle.scI.csueastbay.edu, and this is my login. Um, so let's go ahead and discuss what is XSS and what is Noxes about. So what is cross-site scripting? Now, cross-site scripting, or XSS as it is called in the abbreviation form, is when today's all web applications use JavaScript language, which is used to deploy the front end or design the front end of all web pages. The JavaScript code gets downloaded onto the web browser and is executed by an embedded interpreter. So the JavaScript code is downloaded right there in the web browser when you access or request a URL, and it is executed right then to display all the web contents on the user's browser. Now, a JavaScript code can be of malicious form. It can contain those malicious code which, when downloaded and executed, can provide all the important user session information, all the sensitive data stored in the browser's cookie to the attacker. Now, this is called cross-site scripting, and it is the most common form of attack that's available on or that's on use right now on the web systems. So the web browsers have two mechanisms to prevent the malicious JavaScript code. Now, it's called sandbox mechanism, and another is called same origin policy. Now, sandbox mechanism is the JavaScript code is only allowed a limited resources within the browser. It cannot get into the various parts of the computer, all your private files. It cannot get there. It's only limited to the web browser, and it can get all the information right there, not beyond the web browser. And the same origin policy is when two web pages are connected, their JavaScript codes are protected from each other. Let's say one web page has the malicious code, it cannot go to the other web page and access all the user information from the cookie and give it to the attacker. It is only allowed to the resources within its origin site. So it can do only within its origin site. Now, this is when the JavaScript code is prevented from accessing other web pages, user information, or when it is only allowed to use the browser information. It is only allowed to leak the browser information. But these two forms are not efficient to actually prevent prevent an attack, prevent a cross-site scripting attack. So we will see how what are the types of attacks and how it is done, and what the Noxes tool can do to prevent those attacks. So as you can see from the chart down below here, that the 39% of all the attacks are from cross-site scripting, and only 7% is from SQL injection. And this 32% information leak is when the user himself, accidentally, unintentionally gives all the information to the attacker. There is no need to download a malicious code. So let's go to the types of XSS. There are three types of cross-site scripting attacks. One is stored XSS attack. This is when the malicious JavaScript code is permanently stored in the server, in the database, for example, in blogs or as a comment in guest books. So when a user requests an URL of a page that accesses some information from the database, for example, the page that contains comments, and that comment is fetched from the database. Now that comment itself is a script, which is the malicious script. So it can come back to the user's browser and attack it from there. So this was stored in the database. So this type of attack is called stored cross-site scripting attacks. Let's get to see the other types. The second one is the DOM, or document object model based cross-site script attacks. It is to understand this, let's go and understand how an HTML document can be described as a document object model. So an HTML document has nodes for everything. The document itself is a document node, and all the HTML elements that they have the element nodes. The comment have the comment nodes. The text inside the element, the text inside the HTML has text nodes, and the attributes of the HTML have the attribute nodes. So all these nodes are under the document node. And when an HTML document is downloaded on a browser, the document node becomes the root node, and it gives access to all the other nodes through the JavaScript code. So when a DOM based attack is what it is actually, the elements inside the document, all the different nodes, all the different models of the HTML document behave in a different way rather than what they are expected to do. So the page itself doesn't change, but the behavior of the page changes. So that's when the DOM based attack happens, when the JavaScript code uses all the document nodes, all the nodes of the HTML, to execute in a different way. Now this is not a very common form of attack, but it's out there. Now let's see the third type of XSS attack, which is the reflected cross-site scripting attack. Now it is when a user requests a URL or a web page, and it goes to the server, and the server returns a message, let's say an error message, saying that the file is not found, and it gives an error message with the file name. Now the file name is itself a malicious code. So this is reflected off the server and back to your to the user's browser. This form of cross-site script attack is the reflective, and it is the most common form of attack. So let's see what Noxes is. So Noxes is a tool presented by the authors Kurda and Krugel. Noxes is to prevent and mitigate cross-site scripting on the client side. Now it acts as a web proxy or a web firewall, and all the web connections are made through it. How it does is it has a database of all these rules and policies. Now, when a web connection is made, it goes through those rules and allows the web connection. So how the database is created is by three types. First is the manual creation. The second is the firewall prompts, and the third is the snapshot mode. The manual creation is when the user himself creates all the rules. Let's say, for example, www.xyz.com. I do not want to get any prompts for that web page, so that's a permanent rule. Do not prompt me, and he gives all these lists of web pages that he wants to go without any interruption. So that's when he creates the permanent rules list. And there's a firewall prompt. When a web page is requested, Noxes checks all the rules in the permanent database rule, and if a match is not found, then it prompts the user, and it asks if the user wants to create it as a permanent rule or to make it as temporary. So temporary rule is when Noxes allows the web connection exactly once and without any prompt. So the second time the user goes back again to that web page, Noxes again prompts the user with the same firewall prompt. And the third is the snapshot mode. Here, when the user enters a timed browsing session where Noxes collects all the URLs and domains visited by the user and adds it to the database as permanent rule. So you can see here that here's the user, this is the attacker server, and this is the trusted server. So when a user types in the URL, it goes to the trusted server, then the trusted server sends back with the vulnerable page that has the malicious JavaScript code, and when the user executes that, Noxes can see that the domain in the HTTP header has changed. It's a different domain now, other than from the trusted server. It has the domain of the attacker's server, so it doesn't allow. It checks through the permanent database rule. If it's not there, it stops the connection right there, asks for the user a prompt, and that's how the connection is not made. So it would stop the attack right there. Now let's go to see how it prevents and detects all the cross-site script attacks. So as I mentioned before, that's the basic form of Noxes doing the work with the diagram that I showed. But let's go in details how Noxes does it. So a web page can contain all static links and dynamic links. Now static links are our safest links. So Noxes just ignores static links. They are composed, and they are composed by the server even before the malicious JavaScript code is executed on the client side. So it's safe. So Noxes just ignores the static links. All the dynamic links, so Noxes fetches all the embedded dynamic external links in the web page, and then it goes through all of them by a temporary rule. So it will go to each of the link. It would go to each of the link without prompting the user exactly once. Now, what Noxes does is it matches the referrer header. So if the referrer header has a local link, for example, the C drive or your local hard drive or desktop or D drive, so it's a local link, so Noxes will ignore that. As soon as it sees the HTTP in the header, it knows it's not a local link. So that's when it tries to match the domain. So if the domain matches, that's perfectly fine. If the domain do not match, then it looks for a temporary rule. And if a temporary rule is not found, then it looks for the permanent list rule. If a permanent rule is found, that's fine. If not found, then Noxes prompts the user for action. So this is the most form of XSS attacks, and that I have presented right here, uses the GET request method to implement all these attacks. The post request is done when the user fills out or submits an HTML form. This is when an attacker mimics a login form, a valid login form, and the user has no idea that it's a fake form and gives in all his user and password, and the attacker gets it. That's also called phishing, and it is the most common form of post requests attacks. So we will see that. Let's get to see the mitigating part. So this is when the preventing and detecting was before a cross-site script attack is going to happen, and mitigating is when a cross-site script attack is already happening, how Noxes mitigates that. So Noxes allows a k threshold number of links where k is customizable. A user can change the k number, and so it only allows k number of embedded links to pass through without user permission. So if Noxes sees a web page with more than k links in it, it will not pass any of them. And for each link is used to encode a bit value of either 0 or 1. So usually a user session token is of 150 to 200 bits. Now for an attack to be successful, a victim has to visit a very large number of links to leak 150 bits of information. Now in order to go through that number of links, the K has to be very big, which is why Noxes works best by not allowing that many links. There is a certain allowable limit that the authors have presented. It's about, I think it's 20 to 30 bits of leakage is acceptable by Noxes, which we can see later in the evaluation part. But this is how it is done. It also mitigates all the pop-up and frame-based attacks. Now, if a pop-up, if Noxes sees that a pop-up, the page is a pop-up window, then it checks the referrer header to determine if the parent domain matches with the pop-up domain. And if the match is successful, it's okay. Otherwise, alerts the user. Now, let's go back and see how Noxes is implemented. Now, Noxes is implemented in C# on Windows.NET platform. Now, the authors chose .NET since many of the web application users use Windows, but it can be ported to Java, which again can be used in Linux or Mac environment. You can download Noxes by emailing the authors. It's still under development. It's not released, but you can get it as a free utility tool from the authors by visiting the link here. Now let's see how Noxes does in the evaluation section. I just corrected this link, and sorry about that. I will just change it and it should work. Yes, sorry about that. So the evaluation, let's go back and check if the evaluation still works. It was saved by my cookie. I will correct that when you get to the web page. When you get to finally see the web tutorial. I think the link had the incorrect spelling of evaluation there. When I changed it, I did not change it there in the link. Okay, so the evaluation of Noxes is, as you can see, it's okay for 20 bits. 20 bits is an acceptable range. Even Gmail and Yahoo uses about 200 or 150 bits of cookie values. So you can see by the time it leaks about 20 bits, the user has to click about it's right here, 724,438 links, which is a huge amount of link to give out only 20 bits of information. So you can see that Noxes does pretty well. Although it starts with 55,000, that visiting 55,000 links does not leak any information. That's a very important part there for to see that Noxes, how successful Noxes is. Okay, so now let's go to the annotated bibliography, and you can see I have cited the paper, the research paper that has Noxes in there, and this is what my annotation is, and here are all the authors and their information, and this is my contact information. So that was it. I hope you liked it. If you have any questions or comments, please give me an email. Send me an email. Thank you for watching.